Alrighty, good morning everyone. I wanted to do a video to show you how to do more complicated trig equations. Yesterday I did a small video showing you how to do pretty basic trig equations, mostly when it's solved for you and the fractions on the unit circle are very straightforward. But you'll see in this case, it looks a lot more complicated than I'm hoping you will realize. So the equation is 2 cosine x plus radical 3 equals 0. And right now you're like, wait, this is really complicated. I don't know what to look at. None of these are on the circle, etc., etc. But I do want you to realize two things. One is, you know that you're going to eventually have to rely on cosine. Okay, so that means that we're definitely looking at the first part of the circle, so all of these. I'll just go all the way around. So those are all the cosines, right? But now the question is, which fraction are we looking for? So we can't really do much until cosine is alone. So we need to get rid of these other things that are attached to cosine. So first I'm going to get rid of this plus radical 3. And hopefully you know how to get rid of plus something. So the opposite of doing plus would be minus. Whatever I do to one side, I do to the other. So that'll leave me with 2, like that. And again, the goal is to get cosine by itself, so I still have a 2 stuck in the front. So how would I get rid of multiplication by 2? I would divide by 2. And so really, this is just another way of saying cosine x is negative radical 3 over 2. And that allows you to go to the circle and you can find, okay, where is the x value radical 3 over 2? Let me get rid of the marks I made earlier. So let's see, negative radical 3 over 2. So I see one here at 5 pi over 6, and I see another one here at 7 pi over 6. So your answers to this would be x is equal to 5 pi over 6 and 7 pi over 6. There. Okay, let's move over a little bit. Let's look at this example. So this one says tangent x plus 1 equals 0. So same idea here. We know that we have where we're dealing with tangent, and we want tangent to be by itself. So I got to get rid of this plus 1. So how do you get rid of a plus 1? Minus 1. So an easier way to say this would be, where is tangent equal to minus 1? So here's the one little thing about tangent. So you might remember we did tangent when we were learning the unit circle, but we learned it as the little meme. So remember that the shortcut way of getting tangent is sine over cosine, right? Which on the unit circle means the thing on the right divided by the thing on the left. So we need to look for places where we're dividing and getting -1. So I'll just speed it up a bit. So I know that if I do, let me make it a little smaller. So I know if I do there, oh no, sorry, not there. If I go there and there, this will give me radical 2 over negative radical 2, which is -1. And this one will give me negative radical 2 over radical 2, which is also -1. So the angles that I'm looking at are 3 pi over 4 and 7 pi over 4. So x can be 3 pi over 4 or 7 pi over 4. Okay, let's keep going. So now we're here at one of these. So let me bring this down. Can I bring this down? Yeah. Okay, so now we want to solve this one that says cosecant x is equal to 1. Cosecant squared. So notice we talked about squares before, right? And really you just have to ask yourself, what can we do to undo the square? So if you think back to maybe last semester, if we had something like this, x squared equals 4. If you wanted to get rid of that second power, you would do a second root or a square root, right? So then those would cancel and you would get x is equal to, now here's the important thing when you square root something. You have to remember that you get two answers in this process. You get a plus version and you get a minus version. So the answer to this would be plus or minus 2. Okay, so we have to keep that in mind when we do the same thing here. Oops. So there's the second power. So how do we get rid of the second power? Square root. So this would give us just regular cosecant, and then the square root of 1 would be either plus or minus 1. Now, you're going to the circle and you're like, wait a minute. There's no cosecant on the circle. And you're correct. So you have to think for a moment about who is on the circle that's related to cosecant. So let me remind you of the relationships. So we have sine, cosine, tangent. And here's who they're related to. Sine is related to cosecant. Cosine is related to secant. Tangent is related to cotangent. So which one do we have? Well, we're dealing with cosecant. So according to this, we should be able to turn it pretty easily into sine. So how do we do that? So we can turn cosecant into sine if we flip. So here's the good news. If you flip 1, it's the same thing. So we're just looking for where is sine either plus or minus 1. So let me get rid of the work we've done so far. Okay, so where is the y value? Remember, sine is the y value. Plus or minus 1. Well, I see a plus 1 and I see a minus 1. So that would give us pi over 2 as one option, 3 pi over 2 as one option. So that would be one possible answer, 2 possible answers. Okay, let's try one more, and then let me see, is there anything fancy? Those are pretty doable. Let's try this one. Some of these aren't that exciting. Okay, so let's just try this one. So we have secant x is equal to, secant squared x minus 1 equals 0. So hopefully it's obvious to you that you probably want to get that secant by itself. So we get secant squared x equals 1. Again, you see the square. The inverse of squaring is square root. So this would give us secant x is equal to, be careful, when you square root, you get plus or minus 1. Now you're thinking, wait, secant is not on the circle, and you are correct. But if we go back over here for a second, you'll see secant is related to cosine. So we can turn it into cosine. So we can turn this into cosine as long as we flip the fraction. Well, we're in the same position as last time. So we're just asking, where is cosine x plus or minus 1? I see it right there. So at 0, or don't forget that's also 2 pi. And here at pi. So the options would be 0, pi, and 2 pi. Those would be your answers. Okay, so hopefully that clarifies a little bit. I know there are other examples, but I think we did enough for you to be able to manipulate it a bit. All right, happy studying.